Hello, welcome back to part 2 of constructing arithmetic sequencing. Arithmetic sequences can be described as a set of general rules. Values that can be substituted into these rules can find the recursive or explicit rule for any given sequence. When you're writing a recursive and explicit rules for each arithmetic sequence, you need to remember to try to find your first term and the common difference before you go very far. And so that's what we're going to start with on our first example here. So we have a sequence of 100, 88, 76, and 64. Our first term, so this is our first term, is 100, and we're going to find the common difference by taking 88 minus 100. We're going to get negative 12. 76 minus 88 gives us negative 12, and 64 minus 76 gives us negative 12. So our common difference, or D, is going to give us negative 12. Remember, the recursive rule talks about if the first term is, so in this case, if the first term is 100, then the function of n is the function of the previous term minus 12, because that's our common difference. So this is our D, and then this is our previous term. Okay? The explicit rule is function of n equals our first term, so there's our first term, minus our difference times our previous term. Okay? So then we have 100, that's our first term, negative 12 is our common difference, and n minus 1 shows us our previous term. In example B, we have a set numbers that's 0, 8, 16, 24, and 32. Our first term is 0. The common difference is, if I take 16 minus 8, it's 8. 8 minus 0 is 8. 24 minus 16 is 8, so it is 8. So if we take 8 minus 0, we get 8. The recursive rule is the function of the first term, and that's 0. If the first term is 0, then the function of n is the function of the previous term plus 8, because that's our common difference, for n is greater than or equal to 2. Explicit rule is the function of n is our previous term, or our first term is 0, plus our common difference times our previous term. So we're going to write a recursive rule, an explicit rule for the arithmetic sequence 6, 16, 26, 36, and so forth. So we need to identify our first term, and we need to find our common difference. Our first term is 6. Our common difference, if I take 16 minus 6, I get 10. 26 minus 16 is 10, so my common difference is 10. So if the first term is 6, the function of n equals the function of the previous term plus my common difference. And that's if n is greater than or equal to 2. Okay? So that is our recursive rule. Our explicit rule, if we know what our first term is, our first term, so we have the function of n equals our first term, which in this case is 6, plus our common difference, which is 10, times the previous term. Okay? So this is the recursive rule. This is the explicit rule. Example 3 says write an explicit rule and function notation for each arithmetic sequence. We're looking at the explicit rule. Remember that the explicit rule is the function of the first term plus the difference times the previous term. So let's go ahead and write this off to the side. So we have the function of n equals the function of the first term plus the common difference times n minus 1. So the cost of whitewater rafting trip depends on the number of passengers. The base fee is $50 and the cost per passenger is $25. The graph shows the sequence. So if we have one passenger, it's $75. If we have two passengers, it's $100. If we have three passengers, $125. And if we have four passengers, we have $150. We also have it in a table. First term is 75, second term is 100, third term is 125, fourth term is 150. Now we have to find the common difference. If I take 100 minus 75 is 25. So my common difference is 25. My first term is 75. So if I were to find the explicit rule, the function of n equals my first term, which is 75, plus my common difference, which is 25, times my previous term. There is my explicit rule. B, the number of seats per row in an auditorium depends on which row it is. The first row has 6 seats, the second row has 9 seats, the third row has 12, and so on. The graph shows the sequence. So the first row has 9 seats, second row has, first row has 6 seats, then 9, then 12, and the difference here is we're adding 3 each time. So 12 plus 3 is 15. So the common difference is 3. My first term is 6. All right. So we're going to find, we found it. We did 9 minus 6, and that's 3. And then 12 minus 9 is 3, and 15 minus 12 is 3. Write an explicit rule for the sequence. We're going to substitute 6 for the first term, and we are going to substitute in 3 for D. So the first term, so the function of n is my first term plus my common difference times my previous term. Okay, we're going to do the your turn number 9. Jerry collects hats. The total number of hats in Jerry's collection depends on how many years he's been collecting hats. After the first year, Jerry had 10 hats. Each year, he has added the same number of hats to his collection. The graph shows the sequence. Write the explicit rule and function notation for the arithmetic sequence. So we need to find our first term, and then we need to find our common difference. Our first term in this is what? It is 10. So there's my first term, 10. The common difference, if I take 18 minus 10, I get 8. If I take 26 minus 18, I get 8. If I take 34 minus 26, I get 8. So my common difference is 8. Now they want us to write the explicit rule. So the function of n, my first term is 10, plus my common difference, which is 8, times my previous term. If you have any questions, please make sure you see your teacher. Thank you.